Hello, Professor Rad here, and today we're going to work through an example of identifying the features of a parabola. So in this example, we have a parabola that has been graphed, and it looks like they've graphed the directrix, the vertex for us, and the focus. So we're going to use these to help us identify the different features. So let's identify those features that have been graphed first. So I usually go for the vertex first because it's the easiest to find, whether it's been, deliberately graphed as a point or not. So the coordinates here look to be -1, 1. So our vertex is -1, 1. The focus here is 2, 1. And the directrix is a line. So since this is a vertical line, it's going to be in the form x equals, and here x is equaling -4. Okay, once I find each of those components, then I can use them to find A and write the equation. So let's do that part next. A, if you'll recall, is the distance from the vertex to the focus, or from the vertex to the directrix. It should be the same distance. So let's just count 1, 2, 3, and here we also have 1, 2, 3. So that means A is going to be 3. For the equation component, remember that the shape of the equation for parabola is something squared equals either a positive -4a times something. So I'm going to set that up. Something squared equals either a positive or -4a times something. Now, the something that gets squared is either x minus h or y minus k. If it's a normal parabola, so if it's opening either upwards or downwards, then the something squared is x minus h. And that's because we have the x component being squared, and so it's a function like we're used to seeing it. This parabola is not like that. This parabola is sideways. So that tells me that we're going to have y minus k being squared, and then the x minus h is going to be the other piece that doesn't get squared. And then lastly, to figure out if this is a positive or -4a, I look at the axis that is being eaten. So if this parabola is a mouth, it's chomping on the positive x-axis. So that means this gets to be a positive 4a. So those are my components. And then the last piece is just to fill in the values for a, h, and k. So a we've determined to be 3, 4 times 3. That way. So 4 times 3 is going to give us 12. And then hk comes from the vertex. So this is our hk. So h is -1. So minus -1 turns into +1. And minus 1 is just -1. So there's our formula for this parabola. The last two things we have to figure out are the axis of symmetry and the lattice rectum. So the axis of symmetry and the lattice rectum are not graphed for us. So we have to know how to find those. So the axis of symmetry is the one that runs perpendicular to the directrix and through the focus. So that would be this horizontal line. So horizontal line has the form y equals. And in this case, the y value is 1. The lattice rectum is a line segment. So in my classes, I'm not going to ask you to specify the ends of the line segment. If you're not taking the class with me, your teacher may require you to do that. So make sure you know those requirements or not. But for me, I just want to make sure you know where it is. So the lattice rectum runs parallel to the directrix through the focus. So I find where the focus is, and I envision, in this case, a vertical line running through it. So in this case, it's running through 2, and that's the x value. So x equals 2. All right, so there we go. These are all of the features of this parabola. So that's going to wrap up this video. In the next video, we will essentially go backwards, right? So we're going to take some information about a parabola and see if we can graph it. So looking forward to seeing you then. In the meantime, I hope you have a great day, and bye for now.